Welcome to Structural Intelligence. My name's Owen Keenan. I'm the host of this podcast. I'm a structural engineer, entrepreneur, and tech enthusiast. And this show is all about the intersection between technology, structural engineering, and innovation. Today, we're going to be diving into a topic that's shaping the future of engineering, which is automation and its role in structural engineering. I've got my guest with me today, who's Brent Burgess. He is a senior principal technologist at WSP. He's had extensive experience in structural modeling and automation using tools such as Revit and Dynamo and Grasshopper, but he's also played some key roles in some really notable projects, such as the Boorloo Bridge, which is the Swan River Pedestrian Bridges project. And I guess beyond his expertise, Brent's a thought leader in the industry and constantly is pushing the boundaries of how we can use automation in our engineering. And so today we're going to be diving into things like tools that are driving the innovation, different real-world applications, when automation makes sense, and what the future holds for engineers. So Brent, welcome to the podcast.
Thanks, Kane. Oh.
Yeah, no worries. So I guess that was a quick overview, but I'd love to hear, introduction in your own words. And could you tell us a bit more about your journey?
My journey is quite extensive. Started probably about 25 years ago. My first job at SKM, now Jacobs, I was sitting at my computer, the big towers back then, and there was some guy next to me, the CAD manager, who was creating menus for AutoCAD. And I'm looking at that going, that looks cool. I wonder if I can do that myself. So I had a chat to him and he said, here's a file, have a look at it. So I had a look at the file and tried my own little thing and created my own little menu that popped up in the menu bar for AutoCAD. And I thought, nice.
Yeah, right.
This is cool. So I created my first ever command was zoom extents. I know AutoCAD's got zoom, well, ZE now.
Yeah, that's right. Yeah.
I wrote a command that did it in one rather than Z space, E space. Yep. I did ZE space. So I saved myself a space press. Again, I look back on that going, it's not really a huge thing to do, but at that point there, it sort of got my interest piqued about, if I can do that now.
Yeah, what else can I say?
What's next?
Yeah, that's right.
So I was chuckling on a Lisp course. It was just basic stuff, draw a rectangle with Lisp, even though AutoCAD's got rectangle commands. I was just getting the foundations set for what we can do with programming.
Yep.
And once I came back from that going, I could do all this stuff now. And then probably about 2 years later, they said to me, do you want to go on a VBA course for AutoCAD? Oh, yeah, sure, why not? And that opened up a whole new world of possibilities, given that we've got forms now that we can use. We can create our own dialogues. So I wrote some tools to do certain things, put my own inputs in there now.
Yeah, that's right, yeah.
And just being able to create that and run that myself, again, what's the next thing I can do now?
Yeah, that's it.
So I probably did VBA for probably about 4-5 years. And then when I joined KBR back in 2008, I've been programming on and off for about 6 years by then. It's just Lisp and VBA.
And that's obviously just you doing the drafting, you're doing the other things like that, but adding the layer of programming to it as well.
Yeah.
Which is pretty interesting because not a lot of people, I guess, at that stage would be thinking about that.
Yeah. I get given tasks and go, that sounds pretty boring.
Yeah, that's it.
Sounds like it's going to be repetitive. We have to draw all the purlins on a building. Well, why don't I just pick start point, end point, give it a spacing, and it puts on there for me? Again,
and that's the thinking, right?
Nothing really groundbreaking, no enterprise solutions, just something that can help me be more productive in my job. But so when I joined KBR, I heard about this fantastic thing called AutoCAD.net.
Yeah.
Which is using the .NET framework rather than the COM tools in VBA. That there was an absolute nightmare to begin with because I'm so used to doing VBA. Yeah. Yes, the syntax is similar. It's all sort of like written English. You can sort of fumble your way through it. But whereas in VBA, I want to add a line to the model space. I just go this drawing, .modelspace.add line, give it coordinates, and bang, we're done.
There you go.
That's quite easy. But in .NET, it digs a lot deeper into what you need to do. So you need to get the database, get the model space block table record, open a transaction,
so a bit
create
more
the line,
involved,
add the line, commit the transaction, and that's it. So you go from 1 line to 10 lines.
Yeah, that's it.
The benefit then is if we needed to add 10,000 lines, I'm doing this drawing to add line. That's doing all that stuff in the .NET framework all the time. So
Yeah.
Open transaction, adding line, commuting it 10,000 times. Whereas the other one, I open a transaction, I add by 10,000 lines and do one commit.
Yeah, right. So your journey comes, I suppose, you've started as in programming, and you've done all those sorts of things, and you're seeing the applications for practical and real world applications, and obviously to save time, but there's other things around that. And one topic I think was interesting that I guess we had a chat about previously was when to use automation, and there's obviously trade-offs, there's cost benefit analysis. Do you want to just expand a little bit on that and how to consider?
Yeah, sure.
Like you talked a bit about, I did the AutoCAD shortcut, and that's probably saved you a bunch of time because you're going to be using that quite a bit. But how would you describe when to use and when not to use automation?
I think it comes from experience and knowing how long something will take to program.
Like manually, like.
Yes,
I suppose the programming effort against the actual effort itself. Yeah.
If I use an example, we had someone in one of our teams that had an Excel spreadsheet with all their list of points that were needed to add to a drawing, or pits for drainage and pipes and inverts and upstream inverts, downstream inverts.
Yep.
And then they just had another concatenation command, and then they copied all those cells, paste it in the command line, and it runs it. And I was asked, can we make that a tool in AutoCAD? Sounds reasonable. Okay, let's just take a step back now. How long does that process take you to do?
Yeah.
I get the input from the engineer, or the outputs from them. I plug it in the spreadsheet, copy paste. So it probably takes me, I don't know, a minute each time I do it. Okay, well, how often do you do this? I might do it once a week.
Yep.
Okay, and if I was to give you this tool, how long would that save you? About 30 seconds. Okay, and that tool would take me probably a day to write, 2 days to write. So for me to spend 15, 16 hours on that.
Yeah, that's right. Yeah.
And it's saving you 30 seconds a week.
Yeah. Yep.
That's going to be paid back in years. So at the moment, it's not value for money.
Yeah, that's right. Yeah. That makes sense.
If you tell me that it's going to save you 10 minutes a time, it's you, your team, and everyone else in the company using it.
Yep.
And it's going to take me 4 weeks to write, test, and roll out. But it's going to save everyone, 2 weeks a year.
Yeah.
Well, then we in 2 years, well, everyone 2 weeks. So we've combined that with, let's say, 20 people, 20 times 2, we've saved 40 weeks worth of work.
Yeah, that's
true. Now.
Yeah.
So it's all about just looking at that long-term return on investment.
Yeah.
And there are times where
cost benefit sort of thing.
Yeah, and there are times where you may have the idea and you're going, yeah, that seems like it could work. Yep. And I'll give an example. I had an idea in Revit.
Yep.
To get the scope box oriented to a beam. So when we have our beam in plan, it's in plan. We're not trying to cut sections and muck around with that. In principle, yep, awesome idea. When you delve into the code, you can't actually do that.
Yeah, right. Yeah.
So whilst we have good ideas, and I don't see that they are bad ideas.
Yeah.
Every idea has merit in some way, whether it's the idea of what we're trying to do or the outcome that you want to achieve.
Yeah.
There's always some merit in the input, and I don't think it should be limited to just people at my level. Having the ideas, because they've been doing it for years.
Yeah, that's it. Yeah.
And we know what can and can't be done, and we've trial and error.
That's right.
But when you get the young people who have been drafting for 2-3 years come up and say, hey, I've got an idea. I'm spending all my time doing this and that. Is there any way we can make this faster? And it shows me that they're switched on.
Yeah, and they're thinking about the process, right, as well, too. So,
but it also says to me that they're interested in that space and they want to try and dig deeper.
So along with that question, there's that cost benefit analysis which you mentioned, which is quite a interesting thing, is because when we talk about automation and now AI coming through, it's like everyone's like, just chuck everything on it. But really, there's some practical examples around what's the best cost benefit, and it could be time, it could be other things like that. So another question I had for you was, when was there a time when, like as an example, where the automation made a huge difference? Do you have a practical example of that?
I have many. On one of the major projects we were on, we were going from design to as-built drawings. And obviously on the project, you've got a project drawing number, and all your notes have project drawing numbers, all of your cross-references and project drawing numbers. But for the project we're on, we issue the drawing to our client, the drawing number there to change to the client drawing numbers. So 2,000 drawings.
That's it there.
Someone having to go through and each drawing and go, that's that drawing number change. That's going to be an absolute vast amount of time that's going to be spent, and the potential for translation or transposition risk that you put a wrong number in, you miss one. But I wrote something that allowed us to open up drawings in the background, and we had a dictionary, project drawing number, client drawing number, and it went through text, blocks, dimensions, whatever, and it says, do I have this drawing number here? Yes, replace it with this. And I was able to go home one day, hit run on it, because back then we didn't have laptops.
It was, that's right,
towels, but I could run it overnight, come back in the next day, and it's done. So we can, with automation, we can get work done outside of work hours. We don't need to be there sitting at the computer waiting for it to run or watching it run. And that's the true benefit of automation if it's done correctly.
Yeah, no, that makes sense. So just moving on as well. So in your field, you've got a few different tools that you use. What are some of your favorites? What are some of the ones that are your go-tos that you use every day?
I'm a code monkey at heart. So I'll prefer code programming. Mostly.
So what sort of languages are they? And how do they plug into the ones that you use?
Mainly C#. I like C# because it's structured. I've used Python before. It's a dynamic language. I'm not a huge fan that you can just have one data type or one variable have multiple data types assigned to that. That doesn't sit well with me coming from a coding background. I like to say, look, my variable A is going to be a letter. And if I put a number in there, it's got to go, well, hold on. You can't do that. Whereas Python, you can say A equals the letter A and then A equals the number 1 and go, yeah, that's fine. And then later on down the code, it falls over because it's got an incorrect data type in there. So C# is my favorite. Next would be Grasshopper, the visual programming side of things.
That's right.
But Grasshopper also has got, I can write my own custom nodes using Visual Studio and C#, so I can create my plugins. Inside the program itself, there's C# nodes, so I can create custom nodes within Grasshopper. So if I need to do something that's not complex, but I need a bit more control over it, I can write it and get what I need out of it. If I can't figure out how to do something in the code with the visual programming, I'll write something for myself.
And then those tools, they link to any modeling tools and things like that, or? So
Grasshopper can be linked into Tekla to Revit. We mainly use it for Revit because that's our tool of choice. The engineers use Sophistic as well for their design. So there's a whole interplay between engineering, Grasshopper, modeling. And we're trying to figure out the best way to mix the two. Well, not mix the two, but combine the two. So we are trying to create our geometric model. They create their design model. And then we've got two slightly different outputs. We found that on the bridge we're working on, the engineer would do their design for the cables, we'd have our cables that'd be out by maybe 50 mil, not the end of the world, based, with the pure size of the bridge. But towards the end of the project, we found a way that we could export what we've got from our model into a data file, and they import that into their model. So we've got what they see is what we see.
Yeah.
So if we update ours, we'll update theirs. We did have a point where we'd export the lines of the cable center lines to a CAD file, or to a Rhino file, send it to them, and then they bring it in. But the moment you export that, it's just dumb data now.
Yeah.
So we're able to then get that link between engineering and modeling.
That's great. Yeah.
And the sooner we can find a common workflow that we can go, you do something in your model, push it into ours, and you're in charge of that one now. You're in charge of the beam cross section.
Yeah.
You do what you need, push it to us, and we'll have it in our model. Yeah. Rather than you create.
So it's reflective. It's almost like you've got these two different applications, but you're able to bring them together through some of these tools. Yeah. So rather than out in a data set, Excel spreadsheet or whatever, into the other one, it makes the application a lot better. No, that's pretty interesting. Are there? I know we talked a little bit about some things around. One thing I thought was interesting was the reinforcement modeling.
Yep.
And how that could be used in a lot of different applications, whether it be sort of seeing how the bars are placed, or clashes, or doing up the sheets for the bending of the bars and the bar sheets and things like that. Do you want to explain a little bit more on that?
Yeah, so we haven't really done any automation in that space yet.
Yeah.
But we delivered a pilot project to Main Roads where we put 3D reinforcement in all the elements.
Yep.
And we only documented reinforcement that were in situ elements.
Yeah.
So that project there went down to the contractor on site. They're placing reinforcement using the model, bending reinforcement from the model, and they're placing it.
Yeah.
So we were able to cut down on drawings. What the next step is to try and work with Main Roads to try and leverage that, because they've still got their processes and workflows that they need to adhere to. So it's an evolution. I look back to when we went from hand drawing.
Yeah, that's it.
I was on the drawing board at TAFE.
Yeah,
so doing it that way to then on CAD and hard copies when you got the hanging strips, and then you go from the hanging strips to PDFs. Now we're going from CAD files to Revit with PDFs. And so now we're going just full model.
Full model, yeah, that's right.
And all the information you need is there. So you don't actually need the drawings. All the information you've got in the drawings can be included in the model.
Yeah, it's almost like a snapshot of what is in the model, right?
Yeah.
Isn't it? And I think with particularly in the modeling space and the developments around modeling and how you can go to a certain level of detail and things like that, there is this shift around moving from the old ways, which is the drawing sets and educating the the wider industry on trying to adopt some of these other sort of applications of the models. And that's an interesting piece that you're talking about with the reinforcement, how they were able to sort of place with the model and to be able to see, even when you're modeling, if there's clashes to do with the spacings and other things like that. And I think as time goes on and time comes, there'll be more and more adoption of that. And how do you feel like maybe some of the, whether it be contractors or others that might be late adopters, how can we influence them in helping them to be able to adopt some of these things?
I think one thing that we've found on the projects that we've done through the reinforcement, the process for most projects we do is we issue the drawings for tender, then they go for tender.
Yeah.
If we're able to say, you need this volume of reinforcement, or this tonnage of reinforcement, this volume of this class concrete, this one or this class concrete, and it goes up for tender. It sort of gives the client a bit more reassurance when the tenders come back, and they can almost go, hang on, the drawings say you need X% or X number of bars. You're saying we need 50% more, or conversely, you're saying we need 50% less. So it gives them a comparison point when assessing tenders.
Yep.
But the other benefit is we can then apply safety and design principles as well.
Yeah.
So we've got let's say we've got a 12 meter N36. We can say, hey, what bars are going to be weighing over X kilos?
Yeah.
So we know if there need to be a 2-person lift, 3-person lift, or we need to lift with a crane.
Yeah.
We need to know, getting this precast element out of the mold, it has to be no more than X tonnage. Okay, we can provide that to you now. Oh, hang on, we're at 52 ton now.
Yeah, rather than lines on a drawing where you're trying to figure out, what is this way, or like what's the center of mass when you're lifting this, and that sort of thing. You know?
Speaking of center of mass, that's a good segue there.
Yeah.
On my current project, we've got some people in New Zealand who are doing the 3D reinforcing, like shop drawings, fabrication, place all the reinforcement, and they need to get lifting center of gravities.
Yeah.
So they had a chat to me because they were in Perth recently, last year, working on a project. Right. And I've helped them out with a few tools to help them do what they need to do. And I said, can we get a center of gravity tool? Well, don't see why not. Let's just sit down. What do you need? Well, I want to take into account this and this. Okay, cool. So we calculated center of gravity, and it places a sphere where the center of gravity of that element is, including reinforcement. Because that's one thing that isn't really...
That's right, because you think it's a concrete element, right?
It is, and you may have loaded one end with M36s.
Yeah, that's right.
Because loads other end could be N16s. So it's going to be more heavy to this end.
So it takes into account reinforcement. That's pretty interesting.
But it also, for the mass, Revit only gives you the overall mass of the concrete.
Yeah.
Even when there's reinforcement in there, it still gives you the monolithic mass.
Yeah.
So the tool I wrote, it just subtracts the mass of the volume of the reinforcement from the volume of the concrete. Yep. And then applies the density of the concrete to give you a concrete mass and a reinforcement mass. So
wow, there you go.
In some instances, you're taking out 2 ton of concrete.
You are, yeah.
So, if you've got that limit of 50 ton, and you're at 51.5 tons with your concrete and reinforcement, and then you take out your reinforcement, we're good.
Yeah.
Okay, cool. We don't need to refine our design anymore because we are under. It's not as intuitive to know, hey, I've got these little bits sticking out for shear connection between this element and that element, but the percentage of reinforcement sticking out of the element is probably 0.1 of a percent.
Yeah. No.
So to me, it's negligible, and we need to apply some level of pragmatism and variance to it as well.
Yeah, no, that's an interesting thing. But so, I really like how you went into sort of even down to the basics of the programming. Those are the sorts of things, and the programming thinking and the workflows and stuff like that coming into, which is a geometrical structure. And I'd say one thing that I wanted to sort of jump into briefly is the value of the model and the value of those workflows in changes in a geometrical structure. Because obviously you go through and you do projects, and what happens is inevitably things will change. Always. And so as a snapshot in time, when you've modeled something statically, something that is a change, you almost have to remodel it again, right? But what would you say to that in terms of these workflows and also the modeling practice for automation?
I think depending on the structure type. Obviously, the bridges I've worked on recently, there's a heavy level of computational modeling just due to the complex geometry of the structure itself. Even for straightforward bridges, understanding what you need to do. So I mentioned earlier, we had a bridge recently where one of our modelers used Grasshopper to model the bridge. It was a haunched bridge over rail, screens, very constrained site. So trying to do stuff manually, it can be done. They'll probably take a little bit longer than doing the computational way. But the benefit we found was after we issued for 85%, the client came back and said, actually, this is a really constrained site. We need to move this abutment this way by 4 meters, that one 2 meters. And typically, the first thing you do is you just want to walk out, scream, yell, let your frustration out and come back in. The guy who did it went, okay, cool. He adjusted his center lines of his abutments,
Mm.
hit run, and in 5 minutes, it recalculated the whole model.
Yeah, far out.
So there are a few bits and pieces that didn't quite
Yeah, you
work.
tidied them up, but
if you can get 95% of that modeling done in 5 minutes compared to 100 hours of remodeling.
yeah. What was the effort of remodeling that?
I can't recall off the top of my head, but I got him to do a presentation to our Bridges technical director.
Yeah.
And say, here's what we've done.
Yeah.
Oh, awesome. What's the next step? Can we do this? What was the effort in getting this done initially? So
compared to what was the manual effort?
The manual effort would have been probably about 100 hours.
100 hours, yeah. So you've taken that down to less than a tenth of the time, right?
Yep.
In essence. So,
in terms of other modeling that we've done in automation, I wrote a plugin for Civil 3D a couple of years ago. I've worked on noise walls, retaining walls for years as part of bridge infrastructure. And one thing I've always found, regardless of how good the civil designers are, they will always adjust, tweak, move the alignment.
Yeah.
And when you've got a 1 kilometre long post and panel noise wall, and you're placing your posts at where they need to be and getting them rotated, putting the panels in, just in plan alone, and the next day they go, oh, by the way, I've shifted this 300 mil this way. Okay.
Yeah.
Cool. Thanks for that. So then that 7.5 hours is abortive work that you've done.
Yeah.
And you can't get that back.
No, that's right. Yeah.
So I had a chat to one of our capability development leads in Civil 3D and went, hey mate, is this possible to get this done a better way? Because I'm tired of changing every other day.
Yeah.
And he went, yeah. So he gave me a quick proof of concept and went, sweet. So I went to the project manager and said, hey, there's an opportunity here. What do you think? Gave them the return on investment, your time it's going to take roughly.
Yeah.
And I went, go for it.
Prove the case. Yep.
So I wrote a tool initially in Dynamo because that's what the proof of concept that he gave it to me in. I went, okay, cool. I can do this. Awesome. It works. It gives me plan profile of the plan of wall footings, posts, panels, and elevation.
Yep.
Footings, posts, panels. It gives me data for it all. I'm going, awesome. That's great. I can get 100 meters previously would have taken me 2.5 hours to plan and profile. Once I ran that, it got down to 10 seconds.
Yeah, there you go. Yeah.
And then
so that's the benefit.
And I had all these nodes. I'm going, well, hang on. I'm a code monkey. Surely I can write some stuff here. And Dynamo's got Python. So
yeah, there you go.
chuck my Python hat on.
Yeah.
One input of my alignment string. And I've got, 7 or 8 outputs, bisect angles, deviation.
Yeah, you got it all. Yeah.
I can use that.
That's it.
And then once I did that, it got down to 7 seconds. And then it hit me, hang on, Python's like C#. I can do that and I can write it as a plugin. So eventually we got it into Civil 3D using a C# plugin. We could do plan, profile, 3D model.
Yep.
100 meters in about 1.5 seconds.
Oh, that's great. And that's the application, right?
Yeah. And then if they said, oh, we need to change something, we open the interface, change the value, rerun, the table gets updated. If they say this panel here needs to be longer, we need to have straddle the surface.
Yeah.
Oh, I'll just move these points here, rerun. It recalculates the levels, recalculates everything. So it really saved our time on how we do things.
Yeah.
And the next evolution of that, I want to try and do. Can we do that in Revit now?
Yeah.
So we can assign metadata to that, and we've got everything in there now.
And I appreciate you going through that. It's these sorts of applications where the grunt work, the things that can easily be done by computational logic, really goes into that. I wanted to move on. So one really, really interesting part of some of the experience that you've been working on was Swan River Bridges, the pedestrian bridges, Boorloo Bridges. And I suppose just to give the audience a little bit of a background, what's the structural makeup of the bridges and how do they look and what are they made up?
So it's a steel box girder.
Yep.
Cable stay bridge.
Mm-hmm. Mm-hmm.
Technically, it's a cantilevered cable stay bridge.
Yep.
One of the bridges has a reverse curve.
Yep.
With raked pylons, so you will have one pylon going that way, one pylon going that way, and they're trying to get the cables from the pylon down to the deck.
Yeah. Yeah.
Trying to get the cross sections happening, making sure you have the right profile. So we set it out. Well, one of the guys in Sydney initially set it out because I was busy on another project finalising, and I took it over. And what we found was to get the pylon anchor points.
Yeah, yeah.
He used a plugin called Galapagos, which is a machine learning
interesting
node. And you plug in all your criteria, you give it some failure multipliers so that it knows not to use that one.
Yeah, yeah.
And what it will do is it will iterate up and down the pylon between certain parameters and go, oh, I'm getting closer. And at one point you can just go, yep, cool, I'm happy with that.
Yeah, right.
And then lock that in.
So it uses machine learning to figure out an optimal location for that.
Yeah.
Yeah, that's great. Yeah, yeah.
And then once we found where that was, we created our cable plane, created our cleats, and using all that data to get the geometry created. Don't get me wrong. It was confusing. It was challenging.
Yeah, definitely.
But one thing we did is, rather than have stuff hard coded in there, all the cleats had different parameters that have different radius depending on the size of the clevis anchor, depending on the loads coming into it. The backspan one had different loads, so it may have been a little bit thicker.
Yeah. Or
the higher ones thicker. So we chucked all the data in a CSV file, which backspan, thickness, blah, radius.
Yeah.
And we read that in. The benefit was if the engineers wanted to change something, they can go in and change that CSV file.
Yeah, right. Yeah.
It would update.
Yeah.
Invariably.
And that's loading and that sort of stuff.
Not so much loading, but they would say, cleat 18, I need that to have a thickness of.
Sure. Yeah, yeah. So they know the design of it and they can adjust and it updates in the model. Would that be correct? Or?
Yeah. So if they update it, we run it in our model.
Yeah.
If we need to update it, we can update that. But it just meant we didn't have anything hard coded, and it was all based on external data.
Yeah. Right. Yeah. Yeah. That's the bridges themselves. I've walked across them. They're fantastic. How they've got the cantilever style piers, and then they've got the cable stays coming on one side and leaves it open so you can view the other side. Yeah. And I think architecturally, in the sense of a bridge, they're actually very, very magnificent in a way. Like you go to the other bridge down in Madagarup, and that's a very steel framed and it's less elegant than these sorts of bridges. And I've walked through, and one thing that I really, really love is the simpleness of the connections and the way that there's concealed connections and other things like that, just to make it look like a fluid bridge.
That was one of the
it's fantastic.
Design intents, is it wanted to be a simple, lean, elegant bridge.
Yeah.
One of the bridges has 7 cables. Well, 7 cables each side of the pylon.
Yeah.
And it's a pure engineering exercise. There isn't really any fat on the bridge.
Yeah.
Any extravagance on the bridge.
It actually doesn't look like it. It's like
here's what it needs to be, and here's what it is.
Yeah.
The other bridge, the Point Fraser Bridge on the northern side bridge, we were about to issue for 100%. And there was a design change where they wanted to go from 12 cables to 36 cables, so they could have cable lighting to
so they changed
moving art.
Yeah.
That scared the hell out of me.
Oh
my God, how do we do this now? But because we had the framework set up,
we
were able
That's
to
the thing, isn't it?
we're able to augment our design. I'll say easily. It's not easily, but compared to manual modeling.
Yep.
And then we pushed it out. We did a few checks going, hey, with these cables being above the top one, how does that work? Yeah, no, the loads on the pylon base base plate are too high now. That's not going to work. Okay, what if we move them below top one, in between? Okay, that works. So we could just move it up and down slightly.
Yep.
just to see what actually worked. And eventually we got the bridge delivered a week early. And the bridge opened on time.
Yeah, it was great. Yeah.
So, just having that computational modeling framework set up is essential.
Yeah, I commend the whole team on that. It's a fantastic bridge. I walked across it. What I wanted to do to sort of finish up was something a bit different.
Yep.
So I'm the host at the moment, but I want to hand over to my ChatGPT or AI host.
Yep.
And he's going to ask you a couple of questions to finish up.
Yep.
So if I can do that, and then we'll pretty much be wrapped up. But I appreciate your time. So let's go see if this one works. Can you please interview Brent for the last section of the podcast, as we've just planned in the last conversation?
Absolutely. Let's dive into the final segment. Brent, as we wrap up, let's reflect on some broader topics in structural engineering and automation. The human side of automation. How do you see the role of human engineers evolving as automation and AI continue to advance? Will creativity and problem solving become more important, or will technical mastery of these tools take priority? The future of structural engineering. If you had to predict one major shift.
All right. That's a great question. I think in terms of the use of AI, I'm using AI almost every day. I write my code, how I think it needs to be done, and I chuck it into Copilot and say, can you refactor this? And it'll spit out refined code going, this is a more refined code, more structured, gives you better flow, puts comments in there. I think AI has its place as well for people who want to get into automation. If I'm just starting with something new in Revit or whatever, I'll say to Copilot, write C# to do A, B, and C for me. And it will spit out C# code for me and go, here it is here. The thing I will probably stress there is don't just rely on that, because I've chucked that into my editor and it will put in some methods and functions or properties that aren't actually part of the API. So you do just need to do it with a bit of care. In terms of how we progress, I think AI is going to play a very important part in people enhancing the designs, enhancing what they do, even just asking questions about what's the best way to do this in a language, what's the best way to do this in whatever topic you want to achieve, and then take the feedback, analyze it, and refine it to what you need.
Absolutely, Brent. It's crucial to strike a balance between leveraging AI for efficiency and maintaining a deep understanding of the tools and processes. AI can be a fantastic aid, but it's vital to critically assess and refine its output. This ensures we harness the full potential of these technologies while maintaining a robust understanding of engineering fundamentals. Thanks for sharing those insights. Now, for our listeners who want to follow your work or learn more, where can they connect with you?
They can connect with me on LinkedIn. Brent Burgess on LinkedIn if they want to. That's probably the main one I'd use.
Perfect. So if you'd like to keep up with Brent's latest insights and projects, be sure to connect with him on LinkedIn. Thank you again, Brent, for joining us today and sharing your expertise. And to our listeners, thank you for tuning in. Stay connected with us on LinkedIn and Instagram for more engaging discussions. Until next time, take care.
Great. Thanks, Brent, for coming on the podcast. I really appreciate it.
No worries. Can I just give some final thoughts as well?
Yeah, please give us some final thoughts. Yeah, definitely.
For those who want to get into the programming automation space, I think there's some key learnings that need to happen. One is that you need to be very comfortable with failing. I've been trying to write some code for the last 3 days. It's sucking. I'm getting frustrated because it's not working, so you go back to square one. But the moment you do get it to work, it's almost like a drug. You go, oh, that was such a high there. I finally got it to work.
Yep.
The downside for that is when you are working on those things, I've got in trouble so many times at home because I say to my wife, I'm just going to go do this thing for half an hour. I say Monday 7:30, and I'm working away, and you get so engrossed, and I call it going down the rabbit warren. You go down there and you start doing, oh, that worked. Hey, if I can do that, I can do that. And then my wife comes past, 10:30, I'm going to bed. Why? It's 10:30. Okay, I've lost all track of time because I've been sowing growth. It is important to just give yourself that little bit of like alarms or whatever, just to control yourself, because I've been caught so many times. The next thing is probably just start documenting what you do.
That's good.
Doesn't have to be anything mind blowing, because if you write your code well, you don't need a whole heap of comments. I did a presentation at Built many years ago in the Gold Coast. And one of my tips, one of the things was, back when I write this code, only God and I knew how it worked. Now only God knows.
Yeah.
Because after time, you forget how things work, and it just is key to how we...
Documentation,
of how it works. So I think they're probably the key takeaways.
Yeah, sure.
But, be inquisitive. My advice is try and break the software if you can. Try to crash it.
Yep.
The more you crash it, the more you figure out what you can and can't do. The amount of times I've crashed AutoCAD, Revit, whatever I'm doing, because I get myself into an infinite loop. Okay, lesson learned, won't do that again. Or you try and access something that can't be accessed, or you're accessing a null. Yep. It's frustrating, but the more you fail, the more you learn.
Yeah, no, that's great. Really good insights, I think. Look, we really appreciate your time today being on the podcast. And I think being able to see how the automation can apply to engineering and how it can benefit both some of the manual processes, but really enhance the designs that we can achieve now. And the notable one, which was the Swan River Pedestrian Bridges or the Boorloo Bridges, is a great one. But again, thank you for your time, Brent.
No worries.
Yeah, easy.